So welcome to day 5 review, which is our second day on topic 1. Let's revisit the first free response you did related to chapter 1, which was question 3. Hopefully you've already pulled up the solution and looked at your scoring. A couple of things to notice is that in the scoring rubric, displaying this data graphically, there were lots of different ways you could display the data. So it's important to know they're very open-minded to how you do it, as long as it's an appropriate way, things are labeled properly. Don't forget to label your X and Y axis. If you have a legend because you have more than one set of data, you must have a legend. Sometimes the scoring rubrics will specify if that's missing, you lose points. Part B here is a great example of having to compare two distributions. In the actual scoring rubric, you should notice for Part B, it said to get it essentially correct, that you must interpret in context and compare the differences and the similarities for at least two of the shape, center, and spread. In class, we focus on talking about all three, and I recommend talking about all three of them all the time if you can. But again, on this particular rubric, just two of either shape, center, and spread would still have gotten you an E. Make sure you're detailed enough in your comparisons, again, talking about some of the key similarities or differences, and putting it in context of the real problem. Otherwise, you will start to lose points. The second day of topic 1 is our day 5 of our complete review, and now we're revisiting the normal distribution, which we've been using so much for this latter half of the book, so it should just be secondhand. Please do reread the learning objectives. One of the things maybe we haven't talked about for a while is the looking at the 68, 95, 99.7 rule about standard deviations of 1, 2, and 3 deviations from the center. Some basic key concepts are not to forget how to do the normal CDF in the calculator. Remember, normal PDF does not exist. That's a point distribution, and normal curves don't have a point, but they only have a cumulative. Just lower end, upper end, your mean and standard deviation. You can do the mean and standard deviation. If it's standardized, it's always 0 and 1. If you use your given data in the raw context, you just use the mean they give you and the standard deviation. Remember to compute that z-score where data sits on the curve, or to actually get that individual piece of data, we can use inverse norm. It's area under the curve and then mean or standard deviation. To get the z-score or the critical value, remember the mean is 0, standard deviation is 1. As we dive directly into section 2.1 of this chapter, computing the z-score is just your piece of data minus the mean over the standard deviation. And what that tells you is how many standard deviations your piece of data is from the mean. If it's positive, you're above the mean. If it's negative, you're below. We also saw cumulative relative frequency graphs. Remember, these graphs, if it's relative frequency, it's going to be a total percent. And as the graph moves from right to left, because it's cumulative, you will never see it dip back down. It's always going to either continue to grow or it could be flat, but it'll always grow. Transforming data, what happens when you transform the data, and how do you transform the data? Just remember for this case, when you add a value to your data, that is going to make your measure of center change, but your measures of spread will not change when you do that. When you multiply on your data, your measure of center is going to change by that factor, and your measure of spread will change by that factor, but only its absolute value on that one. The variance itself will change by that factor squared. Since standard deviation is multiplied by the factor, variance would have to be that factor squared. A density curve is really just another name for our particular normal curve. There are other density curves out there. This point here is actually really important, that the mean and median are equal or close to being equal if you have a symmetric density curve. But as your curve is being skewed, the mean is actually going to be pulled toward the direction of the tail. So for example, if you have a distribution that is skewed somewhat to the right in this direction, the mean is going to be pulled to the right. So skewed right distributions, the mean is greater than the median. On the flip side, if you have one that is going to be skewed more to the left, and it looks like this, the mean is going to be pulled down, so the mean is less than the median if it's skewed to the left. You can check if a curve is approximately normal by looking at the 68, 95, 99.7 rule. 68% of the data is 1 standard deviation away from the mean, 95% of it is 2, and 99.7 is 3 standard deviations from that mean. We do have table A that you can use to find probabilities. In most cases, though, we're going to use normal CDF, or we could use an inverse norm to reverse what we were doing before. Normal probability curve plots are not required to be known for this test, but it just shows you a plot really of your z-scores of all of the x variable of your data. So if you see a plot and it's nice and straight, it means you're not going to be seeing any skewness, because that would be your z-scores in relation to all of your data. Again, before you start this official review right here, what I would recommend is pulling out your Chapter 2 note packet, maybe breezing through those notes or looking online at your homework in your archive class. And then you're ready for our 2 participation assignments for today. Your multiple choice on Chapter 2, make a submission and see how you did. And this free response here. Again, you're going to find this in your packet, so you can just go directly there. Try the free response and then open up the assessment here and do your self-grading on it. The free response today comes from the year 2004, and it's problem number 1. Again, 10 to 15 minutes should be an adequate amount of time for this. Typically, I will tell you problem number 1 is considered to be one of the easier problems, whereas when you get to problems 2, 3, 4, and 5, their order is not based on the easiness of it, so they really say it doesn't matter. They would recommend you can page through questions 2, 3, 4, and 5 and see what you want to do first. Again, number 6 is going to be that more challenging one that we haven't seen before, so they do maybe recommend doing that one last, just giving yourself enough time. So good luck on today's review.